Okay, so where we left off last class, I reminded you of our minimum wage study. This was, I think, one of the, uh, uh, it's the sort of the motivating example we used at the beginning of the semester, and I think one of the best motivating examples we can use for the kinds of things we do. As economists, we think about behavior, and we build models of behavior, and we can sit down in our philosopher's chair and hypothesize about the world all we want. But if our models don't hold up to scrutiny using real-world observation, as a field, we generally don't recognize them as useful. So what we do as a field is we go out and we test the models that we write down on paper. One of those models is about minimum wage. This is a great example of the kind of thing we do because you all coming in have seen this model before. When we raise the minimum wage, the price of labor goes up. And according to our model, as we raise the minimum wage, we raise the price of labor, and quantity demanded of labor should go down. So what we did with Carter-Kruger is just go out and test it. So Carter-Kruger looked at minimum wage going up in New Jersey and holding steady in Pennsylvania, and then checked whether labor demand went down in New Jersey relative to the place right across the border in Pennsylvania where minimum wage did not go down. And what they found is that the simple model, the simplest model that we often talk about in our intro classes, did not seem to hold up in that environment. Which tells us one of the other models of minimum wage is likely the correct one. So this is the kind of thing we like to do with data. In this example, you'll remember, we talked through what their data set looked like. We have many stores, we have 2 states, and we have 2 time periods. For now, we can sort of ignore the state variable because store is linked to a state, right? Like stores don't change states. We have a store indicator variable, which is our entity. And you'll remember, we talked through this last class. We have store showing up twice. So each one of our many stores shows up in in both of the waves. So we have our pre-minimum wage wave, and then we have our post-minimum wage wave. So we have many entities showing up at 2 time periods, which tells us a couple of things. One, this is not cross-sectional. We have 2 time periods, and that means this is not cross-sectional data. Store shows up multiple times. It's also not time series, because here we have many entities. We have multiple time periods, wave 1 and wave 2, but we have many stores, so store 1 and store 2. So what this means, this is neither time series nor cross-sectional data. What panel data does is sort of bring these 2 dimensions of index together. We have an ordered index through time, and we have an unordered index across entities. We also have our x. So this is our meaningful variable, full-time equivalent, or just the measure of employment at these stores. So we have our I index, our T index, and our x variable. So this is the kind of thing. This is how we look at data, and this is an example of a use of panel data. I also used panel data in my dissertation, so I have a lot of fondness for this data structure. But it turns out to be one of the more powerful things, one of the more powerful data structures for reasons you can probably already see. So we're going to spend the rest of this week talking about panel data. The first way we look at data, well, you'll remember the definition we talked through. Panel data is just data with repeated observations for entity. So we have many time periods and many entities, like we talked about last time. We have two formats, and this is sort of where we get into some of the weeds on data structures, or on panel data. We're going to talk about two different ways we can organize our data sets. I think one of them is more intuitive, and both have sort of use cases, which means we have to think about both. Okay, so our first panel data structure we talked about was long format. So we talked through this. We have shop. So this is the entity index variable. So we have, you can't see this, but there are many shops, and then we have many time periods, and then we have our meaningful variable, the x, the measure of quantity at the store. So this is coffee shop location, many coffee shop locations, many hours of the day, and then we're just measuring quantity. It's pretty hot in here. Is that right? Or am I just flailing my arms and starting to sweat? We can open that back door. It gets a little noisy, but if we agree to open that, we can definitely do that. I made the mistake of wearing a sweater again. I don't know why I keep doing this. How many of you want the door open? How many of you want it closed? Let's open it. Okay, so we have our definition of long format data, which is what we're going to focus on in part 1.4. And what distinguishes long format panel is that we have each row representing a specific observation at the entity at a particular point in time. So this is at the 12th hour at coffee shop A, or at the 15th hour at coffee shop A. And so what we did, and just as sort of some indexing like we've done, we have a shop, which is the I index, we have hour, which is our T index, and then we have quantity, which is our sort of meaningful variable. And in this case, with long format panel, we have both I and T active. Okay, so we walked through this little setup last class. We were thinking through where should we be hiring a barista, so thinking about labor demand. And we had 3 shops, and we had many hours of the day, and we asked a couple of questions of our data. So you'll remember this sequence. I asked you some questions. So the first thing we should do when we look at data is try to summarize each of the variables on their own. So here, I'm just summarizing coffee shop transactions by shop. And you'll remember we set up these bar charts. So it was just, we went through and counted how many transactions happen at each one of our coffee shops. And this visualization, I think, makes it really easy to know which shops have the most transactions. So you remember this from last time? We also asked these kinds of questions. So what time of day is the busiest? And this question is impossible to answer, first by just looking at the data set, and then second by looking at the figure we just created. So we came up with a better visualization for this question, which was the histogram. So what the histogram did for us in this case was allow us to find what time of day was the busiest. And as you'd expect with coffee shops, that happens in the morning. So you can see a spike before 11 o'clock. Okay, so I asked you this question, which was, does this mean the morning shift at coffee shop A is the busiest? The morning, so we know morning is busiest, and we know coffee shop A is the busiest. Does this mean the morning shift at coffee shop A is the busiest? Some of you said yes, some of you said no, and some of you said not necessarily. It turns out not that necessarily is the correct answer. And the way we know this is by plotting the histogram of transactions through the day, but broken out by shop. So we sort of have, we have time series broken out by all three coffee shop. So we have counts at each hour for each shop. And what we've done here is overlaid the three histograms on top of each other with a little bit of transparency just to allow us to see what's going on. But I think everyone in the room at the time told me that this is a terrible figure. And if you said that, I agree with you. Y'all remember this? So you can answer the question with this figure, but it's just not that easy. You can see coffee shop C has the highest spike in the morning, which tells us definitely not coffee shop A in the morning. So even though coffee shop A is the busiest and the morning shift is the busiest, coffee shop A in the morning was not the busiest. It turns out it was coffee shop C. But this figure was hard to read. You gave me a couple of ways of fixing this. Like, this definitely communicates the data, but it doesn't communicate the data very clearly. Do you remember some of the fixes you offered?
You could stack them on top of each other. That would show the size differences.
So yeah, we could do a stacked, almost like a stacked histogram. Yeah, sometimes we sometimes work with stacked bar charts, so we could do something similar with a histogram. We got this far, right? No? Okay, well let's pause here then. Do you all agree that this is a bad figure? I think this is just incredibly hard to read. Casey likes it. I think, yeah, keep going. So Casey's right here. This figure accurately displays the information we're trying to communicate. We wanted the distribution of coffee shop broken out by coffee shop through time. And it does communicate that. Yeah.
I'm just confused because it's 4 colors and it's only 3 shops.
Yeah, there's actually, I think, more than 4 colors, but there's definitely more than three colors. And the reason is because some of these are somewhat transparent. And so they sort of like add color as you stack them. So Casey's definitely right that this is correctly displaying the information we're interested in. But I would argue, being correct is not all we look for. We also look for clarity in our figures. And I think all of you sort of looking at this figure trying to answer the question do not see clarity. Like, we can answer the question, but it's hard to do. So I would say that figure, I would consider a figure that communicates the data but does so in non-clearly is not a good figure. So we had one suggestion, which was maybe we stack the bars of the histogram instead of overlaying them. What are some others? James.
Could you do a line graph?
So we could use a line graph. Yeah, so we could have separate lines representing the tops of each one of these histograms. So line graph. This is an approach we will take in a second. There are some others. Any ideas?
3 separate histograms.
So Erwin's recommending 3 separate histograms instead of stacking them, which is another approach we'll take in a second. So let's work with these two. I think this is more than plenty. So yeah, I think we can all agree this is not a great figure. I think it shows the data, but it doesn't show it very clearly. So one fix, as Erwin is recommending, is we just split the figures, the 3 histograms into 3 separate figures. This is what we call faceting. So we just break the data out by category. And we'll do this in a second. So let me ask you a question. Which shop has the most consistent traffic throughout the day? You all haven't said hi to each other. Do you all like giving compliments? Is that a nice thing to do? You can either give someone a compliment next to you or tell someone next to you something fun you did over the weekend, and then answer the question. No, it truly is. Okay, someone help me out here. Which shop has the most consistent traffic throughout the day? Shop A. Great. So we have some, there's like a bit of a spike in the morning, but then it's pretty flat throughout the rest of the day. Which, that might be why it's not the largest spike in the morning, even though it's the most traffic. Because a lot of it happens spread out throughout the rest of the day. I'm sorry, remind me of your name.
Thomas.
So Thomas is saying shop A, and I agree. What about this question? Which shop is busiest during the morning rush? Okay, someone want to give me an answer? Shop C. And we've sort of already found this, but we can find it again with facets. Remind me of your name? Kanish? Tanish. So Tanish is saying shop C is the busiest for the morning spike. But pay attention to what's happening to your eyes as you sort of work across these three shops. Is this easy to answer this question? James is saying yes. I see some people in the back saying no. Is there a way we could make it easier to answer this question?
You can plot the y-axis so that way it's easier to see it
Oh,
all.
nice. So one thing we could do to improve this figure is add like vertical axis layers. Just add an axis. Yeah, and that would maybe make it easier to figure out what the heights are. Yeah, what else? So to answer this question, as you were thinking it through, what you did with your eyes is you looked at each one of these heights, and then you essentially drew a line across. So you're doing this like vertical scanning. And you had to make comparisons in height at long distances. This works. Like again, just like our original figure, you can do this, but there's a better approach. If you're trying to compare heights across multiple groups, I forget who it was. Was it? We were talking about line graphs. I think that might have been James's idea. So we can make the comparisons using facets, and facets are really good at showing us distribution comparisons, right? Like we can see the shapes of distributions very easily across facets, but making height comparisons, facets aren't the right approach. What turns out to be the right approach is something that looks like this, where we have lines by shop. This is very similar to the original figure I gave you, except here we've removed all of the extraneous detail. I've pulled out all of the bar component of the histograms and just drawn a line across the tops of each one of the histograms and then separated by color. And if I were to ask you which shop has the highest spike in the morning, this one is much easier to read than either the first or the facets. There's no horizontal scanning. You just look and you find the highest point and which color it corresponds to. Okay, any questions about this? Okay, so so very nice. So what have we done in long format panel? Well, we've talked about panel. This is just repeated observations across multiple groups through time. Turns out to be a very powerful data structure. We've talked about long format, which is just each row representing a separate observation at a point in time for a particular entity. And then we've talked about different ways of visualizing panel data. One of them is faceting, so we just break up the panel into separate figures by component. And then the one I prefer for most things is something that looks like a line graph. So we just pull it all together on a single figure, but then separate by category. Okay, any questions here? Y'all want to do some work? Okay, I see some enthusiasm. That's nice. So we're going to actually create these figures in a notebook. So as always, you can turn to the course page. If you don't have this pinned in your browser, what are you even doing? So yeah, you can just navigate to part 1, hop on over here to exercise 1.4. I've made you a nice notebook. So this is, we're just going to walk through working with this copy shop's data, and we're actually going to make all of these visualizations. My last class, I actually left all the code in the notebook, and all you had to do is just run everything and get all the visualizations. I'm making your job harder. Okay, so what's the first step when we open a notebook? Sorry, say that louder. Save it. So I'm going to go up here to File, and then Save a Copy in Drive. And that saves a copy of this notebook in my Google Drive. I'm going to say this for every time we open one of these for the first 5 weeks. So nice. Do this with your exercises and with your homework and with your projects. Okay, so nice. So we have, I've given you some imports. I told you we can import things using nicknames, and I talked about my nickname in college was Tay-Tay. I actually had someone email me, "Hi Tay-Tay," and then the rest of the email, which I love that. Bold move, and I respect it. I also give you a file path to my website where all the data is held. So this is, we're in part 1.4, and then it's in the data folder. So I'm just going to run this. And this will do all the imports, and then go to the file path. So then I'm just going to load the data set and then print out the header. All right, so we have a lot of variables here. The ones we're interested in are hours and shop. And so what we're going to do is just go through and create the visualizations from the slides. So we're not going to do any sort of big choosing of which visualization types, but we're going to practice constructing these visualizations together. And then you can upload one of the last ones, either the line plot or the facet to Gradescope. Okay, so I want you to start by creating a bar chart representing the transactions by coffee shop in this first cell. Take a crack at this on your own, and then once you've gotten started, turn to your neighbor and tell them, show them your code and show them your figure. And when someone else shows you their code and their figure, you say, you are so good at Python. That's the correct response. That's what you should do. And if you get stuck, there's code in the slides. We'll take about 2 minutes to do this. Okay, how many of you got a nice bar chart? Okay, that's not everyone, but that's good enough for now. Does someone want to walk me through your process for constructing a bar chart? And the correct answer is not, I went to the slides and copied the code. Although that's a reasonable approach. How would I write this out in code? Yes. SNS.count plot. I'm sorry, remind me of your name? Micah. Yeah, that's like the third or fourth time. I'll get it one of these days. Maybe you can quiz me. -10 lecture points. Okay, so Micah gave us count plot. Remember, SNS is Seaborn, and then we're just saying within Seaborn, we want to pull out the count plot function. What do we do next? Someone follow up, Micah. Yeah.
And then you pick your inputs, so data is sales, and then your x-axis would be the column shop. And if you want, you can add a hue to differentiate between shop, and that would also be shop.
Nice. So we'll add a hue in a second. Ryan, right?
Yeah.
So Ryan's saying we're going to give it a data set, which is sales, and then we're going to specify that we want shop to be counted, and then separate it on the horizontal axis. So you could plot this out like this. You can also do horizontal. In the slides, I did this vertical count plot. Any questions here? Raise your hand if you got this. Nice. We have a lot of good coders in the room. Ryan was also saying we could add separate colors by shop. So instead of just going through and counting and using the same colored bar, we could separate by color. This is more than enough for a nice figure. This does the job, but like I did in the slides, we can also separate by color. And Seaborn makes this very easy to do using hue.
I saw there's a column saying there's quantities, either 1 or 2.
Yeah.
So would that, do we need to count that in the, basically the shop?
Yeah, so this is one of those sort of philosophical questions. What we're doing here is counting the number of transactions. So if you bought one thing, or you bought 2 things, we're counting that as just one transaction. But we could go through and actually count up how many items were sold. But that would be a separate visualization. Yeah. Yeah, remind me of your name? Clarence. Yeah, good question. What else? All right, so we're going to add a hue. It's not going to be so useful in this case, but this is the simplest case of using a hue. We're going to use more hues later. So we have x. I'm going to use hue is equal to, and then we add the column that we want to separate by color. So in this case, that's just shop. So hue, and we'll make this shop. And when we do that, we get each one of our shops with a separate color. Okay, any questions here? So next, we're going to create a histogram of transactions by hour. Gemini can give you some code, but like it did for me in the notebook, you can use this, but my recommendation is that you try to write it out from scratch without Gemini giving you code hints. This will test your knowledge better than just copying the AI. Okay, we'll take 2 minutes here, create a histogram, and then we will talk about it together. And then once you've created your histogram, turn to your neighbor and tell them they're amazing at code. Again. James. Yeah.
I'm not sure what, putting a Y in the histogram, usually what a histogram does is it counts by the bin horizontal axis, which then encodes the count into the vertical. So I'm not sure what the Y is doing with this.
It might be creating a heat map. Like a two-dimensional histogram is like a heat map. So yeah, we can chat after class about that. Okay. If you're still working, that's great. Someone want to talk me through what you did? Yeah. SNS.histplot. Let's keep going. Yeah.
And then you put sales for the data.
So we put sales. So we're first using histplot from Seaborn. We use sales as our data set. And then what's next?
Specify the X and hours.
Okay.
And you can choose your bins too.
Okay, nice. So, I'm sorry, remind me of your name.
Hey.
Aiden. So Aiden's saying we're going to specify the data set and then the column we're running a histogram over. So this bins and then counts by bin. That's what the histplot does. And if we do this, we get something that looks like this. This is reasonable, but we can improve this by making the bins better. In this case, we have, 26 hours of a day? Yeah, 26 hours per day. So I'm going to write out bins, and then Aiden's saying let's use range. And we go from 0 to 26. Love that 26th hour of the day. And then we're going to increment by 1. So we run hour 1, hour 2, hour 3, all the way up to 26. And then we just close the bracket. And if we run this, this looks a lot better. The only problem is we have a 26th hour of the day, so let's get rid of that. Okay, any questions? Courtney.
Can you just explain the 0, 24, 1
Yeah, so good. Courtney's wondering what these numbers are. This is, we start at 0, and then we go 0, 1, 2, 3, 4, 5, all the way up to 23. And we do that in increments of 1. So this is the starting number, this is the ending number, and then this is the increment. If we change this to 2, then we get larger bins. Any questions here? All right, so here's our hist plot. Anyone want to see what happens when we add hue? Let's add hue by shop. Any ideas what will happen? Do you love this figure? No. So this is our main histogram, and this allows us to answer what time of day is the busiest. The histogram to construct the multi-histogram, breaking out by shop, we just ran that. So all we do is we add hue, and that gives us the multi-histogram. But I think we can agree that this is not generally the right approach. We can do it, but I want to skip it for the sake of time. Y'all okay with that? So the next thing to do is to create a faceted histogram. And this one is a little more challenging. This is actually a new Seaborn command. So I want to walk you through what we're doing just step by step. I'm going to give you the main command, and then you're going to try to infer how to do this using Seaborn syntax. Okay, so in the code, in the slides, I have this thing displot. So I have sns.displot, and displot gives us faceted a faceted histogram. The first thing we do is we put in the sales data. So just like we do with any Seaborn, we're just going to enter the data directly. So this is sales. And then on the horizontal axis, I want, just like with a histogram, I want x to equal hours. And if I run this on its own, I get this thing. The next thing we'll do is to add a row. And what row is doing is separating horizontally separate histograms for each one of the elements in the column that we're specifying for row. So it's going to create a row according to the categories in the column that we give it. So here, that's shop. So if I run this, it's going to create 3 histograms in a row, vertically. It's easier to see this if we use col. So we'll use column, which sets up separate columns for each one of the categories in the shop categorical variable. Okay, any questions here? James?
Can you still control the bins?
Say that again?
Can you still control the bins?
Yes, so let's do that next. James is wondering about the bins. And the way we control the bins is exactly the same as how we do it in a hist plot. We just specify bins is equal to range 0 to 24 incremented by 1. if we do that, we get a nice faceted histogram. Okay, so everything is exactly the same as with a histogram, except we're using displot instead of histplot. And we can control whether we use columns or we use rows. In most cases, I think columns are going to be better, separate columns by category, but we can even use rows and columns together. So if we have two categories, we can break it out by both categories using rows and columns. So a really powerful tool. All right, you still enthusiastic about this? I'll take that as a yes. So we have two more things to do. We're going to create the line plot, but I want to show you a count table, like a summary table before we do that. You're going to use this in your homework, so I just want to give you some of the code. Let's create a summary table. I want to count transactions by shop and by hour. So I want a table that has essentially the heights of each one of these columns. So I want to count how many transactions are happening at each shop in each hour. And the way we do this is with a group by operation. We're going to spend more time thinking about group by in part 2. But for now, I'm going to give you the code to construct this. So I'm just going to copy this last part over into the notebook. And let me just walk you through what this is. So this is sales. This is our data set. And then what I'm going to do is run this group by function, which tells Python to group everything into groups that break out copy shop and hour of the day. So we're saying, I want to count, I want to create groups based on the hour of the day and the copy shop. And when I run this, it's going to print out something that you can't really read. This is just a bunch of groups. Unfortunately, you can't really look at them nicely. But what we can do is count the size of them. So I'm just going to run size on the end. So this is going to find the size of each one of the groups that's in this thing. And this is a lot of like stringing together dot operators. But if I run this, it gives me this, where I have, for shop A in hour 8, I have this many transactions. And for shop A, hour 9, I have this many transactions, and so on. So this is just a summary table going through and counting how many transactions are happening at each one of the groups, which is essentially just the height of each one of the bars in our faceted histogram. Any questions about this? Casey? So if you're running counts like this, this will just save it as counts. And then if you want to print out the counts, you can just write counts at the bottom. Any other questions? And then the last thing I want to do is just this little thing on the end, just to flatten it out to make it look like just like a regular data set. Any questions about this? Can I get a temperature check? How many of you are feeling very good about this stuff? Hands up. How many of you are feeling fine but not great? And how many of you are not feeling great at all? Okay, if you are in that last category, this stuff is new and complicated. And if you're feeling uncertain about any of it, let's just sit down and chat after class, just to make sure that you do feel confident with what we're doing. Okay, so nice. So we have this count data set, which is just essentially doing the same thing as the histogram. And we want to create a line graph based on these values. The thing we can do is just plot a line graph using counts. So I'm just going to show this to you. The code is in the slides. But this is sns.lineplot. We have counts is our data set. And counts is just this new thing we created by counting up the number of transactions by shop by hour. And then I want, on the horizontal axis, I want hour. So I want x is equal to hour, or hours. And then I want hue to be equal to shop. And when I run this, so we need y is equal to count. And when we run this, we get the line plot that we so desperately were looking for. Desperately, right? Yeah. Okay, nice. Any questions about this? Lovely. This is the line plot. I think this is the best way of visualizing this data set. This feels like a lot of steps to get here. Can I show you a trick? Yeah, Courtney?
Quick question. You know how we put sales as the data to read it? Why did we change it to count and counts?
Oh yeah, so you're talking about
Like to read the data?
yes, right. So when we had been working before with the raw data set, line plot is not going to work to create line plots just directly with the sales data set. What we had to do first was create this this summary table, and then we use the summary table to create the line plot. Yeah, so that's why we're using counts instead of sales. Yeah, good question. Anything else? Any other questions here? Okay. Can I show you a shortcut? So it turns out histplot has a way of doing this by default. You have, there's a question in the homework that has you go through and create these summary tables. So we walked through a way of using the summary tables. But we can actually just directly use histplot to make a multi-line graph. Gemini is just so good these days and writes everything out for us directly. The code is in the slides as well. So if you get stuck, if your version of Gemini doesn't help you out here, I recommend you not rely on Gemini very much at the beginning. I recommend you think through from first principles each step that we're doing. In this case, I went sns.histplot. This is just recreating what we did above, sales, and then x is equal to hours. And then we're going to add hue by shop. And what this does is create that bad figure we constructed at the beginning. I'm going to construct bins is equal to range 0 to 24, increments of 1. And this was the figure that was tough to read. But we have some other options for what to do. I think James recommended essentially what we do is we pull out the bins themselves and just draw a line across the tops of each one of these histograms separately, which is sort of the way we think of what a multi-line graph is doing. And we can just do that directly in histplot. I generally forget how to like the exact syntax for how to do this every time. So if you do too, you're in good company. Essentially, we want this element poly, which just draws a line across the top. Element is equal to poly, which looks like this. But we actually don't want the areas filled. So we can turn off the fill. So we can say fill is equal to false. And if we run that, we get this multi-line graph. This is the shortcut that saves you constructing the count table. Okay. Any questions at this point? It seems like most people in the room are doing fine with this stuff. That's what I love to hear. If you don't feel comfortable, we can just sit down and chat and make sure we figure that out for you. Okay, so you can upload either this one or the faceted one to Gradescope for the exercise. We have one last thing to talk about, and then we're out of here. Yeah.
I'll just ask you.
All right. So the last thing we're going to talk about today is wide format panel data. And I think this is where we start getting into the weeds a little bit with panel data. If I were to ask you, so here I have this data set. I have country code. Anyone know what AUT stands for? I think it's Austria. Austria. So I have this column representing country codes for many countries. And then I have a separate column representing the year for each one of those rows. Then so we have our I index, our T index, and then we have the meaningful variable, which is coffee consumption per capita. And I have this for 34 countries between 1990 and 2019. If I were to ask you a question like this, is the world drinking more coffee in 2019 than in 1999? How would you, I actually want you to spend a second thinking about how you would use this data set to answer that question. Is the world drinking more coffee today than it was 2 decades ago? And maybe like think through the procedure you would follow to construct a summary, like a visualization that would allow you to answer this question. Like, what would that look like? And how would you do it from this data? Let's spend like 2 minutes. I'm going to think it through and then tell your neighbor a general thought process for how you would think about constructing a visualization for this question from this data. I know it's hot, surprisingly.
This is just Austria. I assume it has other countries if it's there.
Yeah.
But I'm just ignoring it. I just want the year and time series.
Yeah, don't second guess yourself. This is actually a very challenging question.
And then you just
Which is
look
part
at
of the point.
Oh,
Remind me of your name? That's right. You were out. You emailed me about being out last week. Yeah, no worries.
it really is.
You could try following in your and you just chat about your actually Courtney.
Also, it would be in the. I think it's whatever
Yeah,
it doesn't seem that hard.
there's also the
fair capstone. If we're talking about gradient, I'm pretty sure even the data is possible, basically. It's either C or yeah, it's basically
Okay, someone help me out here. So if you're looking at this data set, you're thinking about this question, which is how, like, is coffee consumption higher today than it was 2 decades ago? You have this data set. What are you doing with it? Like, what's the kind of visualization we would want if we were trying to answer this question? James.
I said to group by year, use a line graph. Because we would do SNS that line graph group by year, and then you would do some consumption by the year.
Okay.
And then you would graph it.
So James is saying, let's create a line plot essentially measuring like total coffee consumption across all these countries. Yeah, so that would be a nice way of doing this. What are some others? Yeah, Ryan?
I'd set a box plot because you could see, like, maybe you want to look at which one has the biggest outlier, which one has the highest median, which one has the highest outlier on the bottom. So that's what a box plot is.
Yeah, nice. So sort of taking a total can give us one picture, and then showing the distributions by year could give us another picture to show us, you know, how the distributions themselves have changed. Yeah, so that's another good idea. What else? Those are two really good approaches. And we're going to use box plots quite a bit here at the beginning. We'll come back to line graphs in a second. But I just want to give you a bit of a picture into why long format panel data is relatively challenging to use for this kind of question. This is, you'll recognize the data structure, right? Like, this is panel data. We have our I index and our T index, and then our meaningful variable. But if you're thinking about how you would construct a box plot, we can do it. And we can construct histograms using these kinds of data. Like, we've just done some work in that way. But if I'm comparing between countries, I would have to compare, like, Austria in 1999 and 2019. So we're comparing those two rows against each other. And comparing two rows against each other is, I mean, computationally, it's easy, but most of our software is not set up to do it that way, which is part of the reason we use what we call wide format panel data. So let me just set this up for you. Instead of having one row representing an entity at a particular point in time, wide format, it's the same data, but just organized differently. Wide format panel data, we have each row representing one entity, and then each column representing a separate point in time. And what this does, I think for me, this is a more intuitive way of organizing panel data, because we have the index dimension on the vertical axis, each row, and then the time dimension represented by separate columns on the horizontal axis. And what this does is allow us to do special things with panel data. The reason we have two formats for panel and we don't have more than one format for cross-section and time series is because we have two indexes that matter. There's just one format for time series, one format for cross-section, but there's two formats for panel because we have these two indexes. Okay, any questions about this? If this feels like it's in the weeds, I'm going to show you why this actually is useful in practice. If we're comparing between 1999 and 2019, all we're doing is comparing between these two columns, where before we had to think about which row we were comparing to for the same country. And this makes our job much, much easier. for a lot of kinds of questions. All right, so here's a picture of wide format. Each year is a column, each row is an index, and then long format is where we kind of squish everything. Each row is representing an index time. These are the same data just organized differently. So it's not like we're adding data by moving from long format to wide format or vice versa. This is the same data, just organized differently. Okay, so let me show you an example of why wide format can be useful. So let's say I ask you this question. Is the world drinking more coffee in 2019 than it is in 1999? And I show you this figure. What else do we need? 2019. So let's add a second histogram on top of our original one, showing the distribution not just of 2019, but also of 1999. Okay, so do you all like this figure? Is the world drinking more coffee today than it was 2 decades ago? If you're uncertain, that's because the figure isn't doing its job. I think this is a better figure than the first one we started off with, 3 coffee shops. Tell me why this is not a good figure. Like, with all this practice we've done thinking about visualizations, why is this not doing its job? Courtney?
It looks like there's a possibility of actually reading in different years. Because the colors.
So we have 3 different colors, but 2 different years. So that third sort of overlapping, like multi-shade, is making it somewhat challenging for us to read. What else? Yeah, what are some of the other things?
I was just gonna say, like, I don't really see how it's like visually like good in it's just like too confusing. Like she said, with like the colors.
Yeah.
But,
So interesting, like just generally very
overall,
confusing.
like, I don't really like. What would this be like good for? Just like generally.
I spent 2 hours on this figure. Isn't it great? No, I agree. I didn't spend 2 hours on this figure, but I did spend some time on it to show you that it's not very good. There's a lot of moving parts. And it's somewhat challenging to read. Yeah.
If we're asking who's drinking more coffee, there's not like or which year's drinking more coffee, there's not like a clear distinction, like telling us yes or no, or which one.
Yeah. So like, what are we comparing between the 2 years?
Yeah.
Is it like, is the maximum increasing? Is the minimum increasing? Are we comparing the means? Medians? Like, what is it that we're comparing between these 2 years? And that's not clear at all from this figure. Yeah, remind me of your name? I'm sorry.
Wyatt.
Wyatt. Any ideas for what we could do better? How could we want to ask this question: is the world drinking more coffee? And we're going to ask this in a bunch of different ways. But how can we create a visualization that makes it easier for us to see the answer to this question? Yeah.
Okay, well, if it's like asking like about the entire world, and it's I don't think it should be separated per country. I think we're being the total wouldn't be an issue.
Okay, so Jackson's saying we're asking a question about the world. Why don't we just like take an average, almost like James was saying earlier? And that would be one approach. Sometimes we like being specific about the distributions, and so maybe it turns out there is a way of showing how the distribution changes, which gives us not just how the average is changing, but also some of the internal distribution and how that changes through time. Any ideas for how we might do that? you already have the tool to do this. Like we talked about this visualization tool. James?
Would you do a regular bar graph? Like just regular 2x2? And then you just compare them, like some data and 2019 data, and you just do coffee consumption per capita.
So like almost like an average.
I mean, it's binary data, so it's just, you can just, what would you just do? Coffee consumption per capita.
Yeah, so there could be a way of setting up using 2 bars. But I think no matter how we set up 2 bars, we would lose some of the variability within the year. But I think we're getting closer to the right answer here, or like I think a better answer than this one. I think we're getting closer to it. Any other ideas here? Yeah, Wyatt.
We could just go by country instead of by consumption for like a line graph or something, or like a multi-bar graph. I know it'd be a little noisy.
Like a multi-line graph.
Yeah.
Yeah, so we could plot just a multi-line graph, each line representing a separate country. We have 34 countries, so I think that might get a little messy, but definitely something we could do. Box
Yeah.
plot.
Box plot.
So James is saying box plot.
What's the other one called? With the dots.
Oh yeah, box and strip plot.
Yeah.
What if I plot a box and strip plot? Is this easier to read? So we've shown these 2 years, 1999 and 2019. And we've also shown the quartiles. So not only are we showing the actual data and the distributions, but we're showing some of the summaries. And this figure, I think, makes it much easier to see that the answer is yes. We are drinking more coffee in 2019 than we were 2 decades ago. Okay, I think this is one of the clearest examples of when we use the right visualization, the answer to the question becomes very obvious. I think it's very obvious to see coffee consumption is increasing using this figure versus the histograms. I'm going to back this out even further. I think part of the reason this works so well is because you can see the quartiles. We have a bunch of structure given to us by the boxes, each one of the quartiles, and we can see how they've changed. Okay, so we had 5 different years, and all I'm going to do is plot out each one of the 5 boxes. And this shows us sort of the evolution of how coffee consumption has changed between 1999 and 2019. Okay, we're right at the end of time. We're a little bit behind schedule. I guess we'll pick this up here next time. I have a bunch of sub-questions I want to ask. We'll get through them pretty quickly next class. Can I leave you with a parting question? We'll talk through this stuff next time, but I want you to think about, sorry, I told you could go and now I'm saying, here's one more question. Can I leave you with a parting question? So, here's my question to you. In which year did most countries increase their coffee consumption? This is the parting question number 1. A related question is this one. How many countries increased their coffee consumption between these 2 years? Like a number. This is a question we can answer. The answer is in our data set. This is a better figure than we constructed with our histograms, but there's a better tool to visualize the answer to these questions using this data set. And that's what we're going to do next class. This is my favorite one. We'll talk about it next time. Go get out of this hot box. It's so hot in here.